Hello, welcome to today's lesson. Today we're going to be talking about the differences between temperature and heat. So, what is heat? As we saw earlier, some chemical reactions feel hot while others feel cold. In order to understand why this is, it's important to understand a few things about energy and a little about kinetic molecular theory. Energy is the ability to do work. The SI, or Système International unit for measuring energy, is the joule. Kinetic energy, molecular theory, is the idea that all matter is made up of tiny particles that attract each other and have kinetic energy. Kinetic energy is the energy of motion. Therefore, particles of a substance are in motion. When a substance is heated up, particles begin to move more rapidly. This may only be a vibration if it's a solid. When substances cool down, their particles move more slowly. Potential energy. The particles of a substance may also have potential energy. Potential energy is stored energy, and it may be stored by the position, or it may be stored in the chemical bonds or many other places. So to form a bond, it needs energy, and to break that bond, when you break that bond, all that energy is released. So the potential of the energy in the bond is why we call it potential energy. The total amount of potential and kinetic energy contained in the particles of a substance is referred to as thermal energy. The thermal energy of a substance determines how fast the particles of a substance move or vibrate, and therefore determine how hot or cold it is, i.e., its temperature. Temperature is the measure of the average kinetic energy of the particles in a substance. Temperature can be measured using a thermometer. A traditional thermometer used a glass tube filled with a liquid, usually alcohol or mercury. And we will learn in a couple lessons about how and why things expand. And as things heat up, they expand, and as they cool down, they contract, which is how the thermometer works. Units. Temperature can be measured in a variety of units. The most common one we use in Canada is this degrees Celsius. Degrees Celsius is based on pure water at sea salt. André Celsius defined the temperature which pure water freezes as 0 degrees Celsius and the temperature at which it boils as 100 degrees Celsius. The scale commonly used in the United States is the Fahrenheit scale. Daniel Fahrenheit was based on the freezing point of a brine solution. Pure water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. The Kelvin scale. In science, the most commonly used temperature is Kelvin. This is the SI unit. Lord Kelvin based his temperature scale on the idea of molecular motion. The temperature at which particles have no kinetic energy is referred to as 0 Kelvin. This is sometimes referred to as absolute zero. And this is because when there's no kinetic energy, particles will stop moving. So even in a solid, particles are consistently vibrating. At absolute zero, they will stop moving. No one has been able to reach absolute zero. They've come very, very, very close, but they can't seem to get over that last little bump to get them to zero molecular motion. 0 degrees is negative 273.15 degrees Celsius. The size of a degree Kelvin is the same as the size as a degree Celsius. So this makes converting temperature easily. So to change from Celsius to Kelvin, you're going to add 273 to the degrees Kelvin. And to convert from Kelvin to Celsius, you're going to subtract 273 degrees from the Kelvin. Thermal energy. Substances increase in temperature when they absorb thermal energy. Substances decrease in temperature when they release thermal energy. When a solid gains thermal energy, the particles in it begin to vibrate more quickly. If a substance gains enough thermal energy, so in other words gets hot enough, the particles will vibrate out of their fixed position and begin to move more easily. The temperature at which this happens is called the melting point, and it's when a substance turns from a solid to a liquid. When a liquid gains enough thermal energy, the particles begin to move more quickly. If the substance gains enough thermal energy, the bonds holding the particles together will begin to break down, and the particles will move apart and to become a gas. This is called the boiling point. Going the other way, the temperature at which a gas changes to a liquid is called the condensation point. The point at which a liquid changes to a solid is called the freezing point. Different substances have different melting and freezing points, and boiling and condensation points. And these temperatures can be affected by other factors such as pressure or presence of other materials. Thermal energy versus temperature. Thermal energy and temperature are related to each other, but are not the same thing. Remember that temperature is a measure of the average thermal energy of a substance. It's possible for a substance to have the same temperature but different amounts of thermal energy. How? The answer to the above question comes down to mass. A substance with a greater mass will have a much greater amount of thermal energy because it has more particles. Think of a bathtub filled to 50 degrees Celsius with water at 50 degrees Celsius and a teacup of water at 50 degrees Celsius. Both of these substances have the same temperature, but there's a lot more water in the bathtub than in the teacup. Therefore, the total energy in the bathtub is greater than the total energy in the teacup. You can also think of it this way. The bathtub will take a lot longer to cool down to room temperature, whereas the teacup will probably be cold within the hour. Thermal energy versus heat. Recall that thermal energy is the sum of the kinetic and potential energies of the substance. But what is heat? Heat is the transfer of energy from a warmer substance to a cooler one. Think about heat as a verb, while thermal energy and temperature are nouns. Temperature is the measure of a thermal energy, while heat is the movement of thermal energy. When you use a hot plate to heat water from 20 degrees Celsius to 80 degrees Celsius, you are transferring thermal energy from the hot plate into the water. Like thermal energy and all types of energy, heat is measured in joules. Make sure when you know the difference between heat, thermal energy, and temperature. There are different ways that thermal temperature can be transferred. We'll learn that in the next few slides. Thermal conduction is a transfer of thermal energy that occurs when two substances touch each other. In order for thermal conduction to occur, the substances must be in physical contact with each other, and they must be at different temperatures. Thermal energy will transfer from one substance at a higher temperature to a substance at a lower temperature. The speed at which this transfer occurs will depend on the nature of the substances. Conduction is also the way heat moves through a solid. If you add thermal energy to one part of a solid, it will eventually spread throughout the entire solid by conduction. Again, the speed at which this happens depends on the substance. Convection is how heat is transferred in fluids, liquids, and gases. Think about heating a pot of water on the stove. By conduction, the burner of the stove will begin to transfer energy from the bottom to the bottom of the pot that the water is in. The water at the bottom of the pot is heated and becomes less dense and begins to rise to the surface. Colder, more dense water from the top sinks to the bottom and begins to heat. It then rises and replaces the cold water, and so on. The continual cycling of water is, as described above, becomes a convection current. Convection current can also occur in gases. Convection currents are very important in cycling the atmosphere on Earth and the water in the oceans. Radiation is when heat is transferred through electromagnetic waves. Radiation is how heat gets to the earth from the sun, or why a lamp feels warm even when you don't touch it. Radiation can be transferred through a substance, but can also be transferred through empty space. Some substances transfer thermal energy very well. These substances are called thermal conductors. Good examples of thermal conductors are metals. When you touch a piece of metal at room temperature, it will often feel cold. This is because it will quickly conduct your body's heat away from your hand. When you touch a piece of metal that you've been heating, you are at risk of burning yourself. This is because it will quickly transfer that thermal energy to your hand. We commonly make pots out of metal because they conduct heat so well. Some substances transfer thermal energy very poorly. These substances are called thermal insulators. Good examples of thermal insulators are plastics or cloths. We often make the handles of cookware out of plastic because it won't conduct heat well, so we won't burn ourselves. Many animals grow a thick layer of fur in the winter. This is because it traps a layer of still air near the animal's body, and still air transfers thermal energy poorly. We also make use of thermal insulators in our home: insulation, clothing, feathers and air pockets, and food storage devices, such as thermoses and coolers. Thermoses make use of the best thermal insulator of all, a vacuum. Between those two walls of your thermos, there's nothing, no air, no nothing. They suck everything out, and because there's nothing in there, the heat cannot be conducted through the metal wall because there's nothing to allow convection to occur between the two walls. All right, that's the end of our lesson, and I will see you tomorrow in class.